Have you ever picked up a bottle of rubbing alcohol, mouthwash, or even cologne and noticed those tiny little percentages on the label right next to the letters V/V? Well, today, in this explainer, we're going to decode the invisible math of percent by volume.
I want you to picture something for a second. Visualize that standard bottle of disinfectant sitting in your bathroom medicine cabinet right now. You look at the front, and bold as day, it says 70% VVV. So what is that label actually trying to tell us? I mean, is it 70% stronger than a regular bottle? Does it kill 70% of germs? Well, no. Let's dive into this because the truth is completely rooted in a very specific and actually kind of fascinating mathematical mechanism that governs exactly how liquids are mixed. Percent by volume, which, by the way, is exactly what that little percent V/V stands for, tells you precisely how many milliliters of a liquid solute are present in every 100 milliliters of the total solution. That's the core rule here. It's a precise ratio designed to keep liquid concentrations consistent. And it doesn't matter if we're talking about a tiny pocket-sized hand sanitizer or a giant industrial vat of the stuff. The mechanism stays exactly the same.
Now, notice this massive number here, 100. You literally cannot understand percent by volume without anchoring yourself to the number 100. The word percent actually translates to per century, or for every 100. So no matter what size bottle you're holding in your hand, this formula mathematically scales the whole thing down to ask one simple question. If we only had exactly 100 milliliters of this liquid in total, how much of the active ingredient would be in it?
Okay, moving right along to section 1, the core formula mechanism.
Before we actually do the math, we absolutely have to get our vocabulary straight. On one side, we have our solute. This is the active substance being dissolved. Think of it as the pure alcohol, the pure flavoring extract, or the essential oil. On the other side, we have our solution. This is the total final mixture. It's the solute plus whatever liquid you use to dilute it, which is usually just water. The absolute most crucial point here is to never confuse the ingredient you're adding with the final volume of the whole batch once it's completely mixed together.
So here's that central formula mechanism in action. And honestly, the math is remarkably elegant. To find the percent by volume, you just take the volume of your solute, that active ingredient we talked about, and you divide it by the volume of the total solution. Then to turn that resulting decimal into a clean, easy-to-read percentage, you just multiply it by 100. Volume of solute divided by volume of solution times 100. It's a beautifully simple engine once you look under the hood and see how it runs.
But wait, because this is exactly where most people mess up. Keep a close eye on the denominator in that equation. You must always divide by the total solution, not just the liquid you use to dilute it. For instance, if you have 10 milliliters of alcohol and you add 90 milliliters of water, you do not divide 10 by 90. No way. You divide 10 by the new total volume, which is 100. Ignoring that final total volume is literally the single most common mistake in laboratory chemistry, so keep your eyes glued to that total final volume.
All right, section 2, step-by-step calculation. Let's break this down into 3 concrete, easy actions. Step 1, measure the volume of the liquid solute. Basically, you pour out your pure active ingredient and note how much you have. Step 2, dilute it, and then measure the total volume of that final, newly mixed solution. Step 3, do the math. Divide the number from step 1 by the number from step 2 and hit multiply by 100 on your calculator. It's a perfectly linear, totally logical process.
Let's set up a quick scenario to prove it. Imagine you're in a lab. You measure out exactly 25 milliliters of pure ethanol, right? That's your solute. Then you add water to it, diluting it, until the total volume of the liquid reaches exactly 100 milliliters. Following our core mechanism, we take our solute volume, which is 25, and divide it by our total solution volume, which is 100. 25 divided by 100 is 0.25. Multiply that by 100 and boom! There it is, a 25% VV concentration.
Let's look at another example. Actually, let's bring it back to something super relatable, that bathroom medicine cabinet we pictured earlier. Say a bottle of disinfectant is formulated so that it contains 70 milliliters of pure isopropyl alcohol housed within every 100 milliliters of the total liquid inside that bottle.
We just plug it into the exact same formula. 70 milliliters of solute divided by the 100 milliliters of total solution gives us 0.7. Multiplied by 100 and punch up the final math, yep, we get 70% VV. So the next time you see that label on the bottle at the pharmacy, you know the exact physical reality of the liquid sloshing around inside. For every 100 milliliters you pour out, exactly 70 of those are pure isopropyl alcohol. And hey, here is a fantastic pro tip for you. It's a quick shortcut, so you never even need to pull out a calculator at the store. Because the central mechanism of this math always anchors to that base of 100, reading these labels is instantly intuitive. If you grab a bottle of vinegar and it says 5% V/V acidity, that just means there are exactly 5 milliliters of acetic acid in every 100 milliliters of the liquid. It's just a direct one-to-one translation when you look at it per 100 milliliters. Simple as that.
Section 3. Real-world liquid applications. This formula isn't just for show. It is relied upon heavily across a ton of industries for safety, consistency, and quality control. You're going to find it on alcohol solutions, like your rubbing alcohols and medical spirits. It's the absolute standard for perfumes and food flavorings, like vanilla extract, where the concentration dictates the pure strength of the center taste. It is totally vital for disinfectants, to ensure they're actually concentrated enough to sanitize your counters. And of course, it's the foundational language of chemistry for almost all liquid laboratory preps.
Which brings us to our final stop, Section 4, the Golden Liquid Rule.
Now, this rule is strict, like a hard boundary. You use percent by volume only, and I mean absolutely only, when both your solute and your solution are measured as liquids. The whole mathematical mechanism completely falls apart if you try to use it to dissolve a solid powder into a liquid or a gas into a liquid. It's a volume-to-volume ratio designed exclusively for mixing liquids into other liquids. That is exactly why it's a V/V.
And that brings us full circle. You now completely understand the central mechanism behind one of the most common labels in your entire household. You know the formula inside and out, you know the critical difference between the solute and the total solution, and you know the golden rule of keeping it strictly liquid. So I'll leave you with this. The next time you open your medicine cabinet or walk down the cleaning aisle at the grocery store, take a closer look at those bottles. What other invisible math is hiding right there in plain sight, just waiting for you to decode it? Thank you so much for hanging out with me for this explainer. Stay curious, and I'll catch you on the next one.